Okay, everyone, Mr. N, we're back, Unit 2 review. Let's solve this problem that will be on your test. You will have a similar problem. Let's remember how this type of question should be answered, right? Which of the following best describes the set of even integers from 12 to 20? All right? And to answer this question, you have four options. But you definitely need to recall what even number means, right? Or even integer. Even integer will be an integer that is divisible by 2, and I believe you guys should have no problems in identifying them, right? 2, 4, 6, and so on. You go up by 2, or you can go with their opposite, right? -2, -4, -6, and so on. So talking about from 12 to 20, I'm looking for all the even numbers from 12 to 20, including 12, including 20. Is that a null set? I don't think so. Is that 12, 13, 14, 15, 16, 17? Well, this will be all the integers from 12 to 20, but I need only the even, right? So this is not a good answer. Option C, 12 and 20. Well, 12 and 20 are not all the even integers. They're only the, the first and the last. So obviously, the answer to this problem would be 12, 14, 16, 18, 20. You count by 2 if you want, and that's how you get all the elements of this set that describes the even integers from 12 to 20. Okay? Next problem, prove that, talking about algebraic proof, we didn't have that class connect, but you guys had enough material into your, website, into the course. To prove that, you have to follow the steps, basically simplify, each one of the sides eventually, and see if the two sides are equal. Obviously, we have an equation. What is that? Two equal expressions, right? And it seems that the left side could be simplified, and I can write it in a better way. Well, first of all, do you guys remember that multiplication is commutative? If I have A times B times C, I can rewrite it as A times C times B, or A times, well, let's put B times A times C, and so on. You can switch places, nothing changes. And this is what I'm going to do here. I will rewrite the left side as 7 times 2 times 1 minus n, right? Well, so what property we use here? The commutative property of multiplication. Now the next thing, I will follow order of operations, and I'm going to multiply 7 times 2, that's 14. 14 times 1 minus n. Next, using distributive property, you will multiply this 14 to everything inside the parentheses, right? So I will have 14 times 1, which is 14. What is the operation inside? Minus 14 times n will be 14n. Well, this is exactly what we have on the right. I proved it. We're done. This is, basic algebraic proof. It may look easy, but trust me, there will be some more complicated things to prove in algebra. This is just the first step, just the beginning. Okay? Moving on. Simplify. We have a problem with absolute value, right? And we have lots of negative signs inside. Now there are many ways to solve this one. First of all is to realize that you have a number inside your absolute value brackets, and then you have minus, 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 whatever, 3 times negative signs here. But I will know that regardless, what the sign of this number will be after I'm removing all the parentheses here, I will still have the distance to 0, which, is representing the absolute value. If I will have -3/5, or I will have its opposite 3/5, their absolute value will always be the distance to 0, which is positive, and will also always be 3/5. So you know what? You don't even have to care about what this three negative signs will reduce to. You're just going to say, hey, this is 3/5. Okay? Now, if you don't see that, you may say, well, first of all, parentheses, right? Starting from the inside out, I have minus minus. They will become a plus. So eventually, this problem will be nothing else but the absolute value of negative 3/5. But the absolute value is always positive, equals to, how many units you're away from 0, 3/5. And that's why the answer to this problem is going to be 3/5. C not good, D not good, A not good, obviously. And you're done with it. Okay, next problem. Which value of M makes the statement true? Right? So we have an inequality here, and we have to decide which one of these four values will make my statement true. Now, there are many ways in which you can solve. One way is to take each one of the A, B, C, D answers, plug them in, and see if the statement stays true. Another way would be to solve the inequality. I mean, we did this in the previous years. The fact that we did not cover yet inequalities in our class is not an excuse for you not being able to solve it. However, for the purpose of this lesson, you will substitute in every one of the options. I'm going to take 9, right? And I will say if M equals 9. If this is a constructive response, this is the way you have to go. You're going to say if the value of M is 9, your expression would be what? 81 minus 2 times 9 less than or equal to 7 plus 2 times 9, right? 81 minus, because the order of operations requires me to multiply first on both sides. 81 minus 2 times 9 is what? 18. Should be less than or equal to 7 plus 18, right? 81 minus 18, 8 out of 11 is going to be 3, right? You borrow 1. 1 out of 7 is going to be 6. Is 63 less than or equal to 7 plus 18 is going to be 25. Is that a true statement? I don't think so, right? Next, you are moving on to 20, right? And you're going to say, well, if M equals 20, what is my expression becoming now? And you will have 81 minus 2 times 20 less than or equal to 7 plus 2 times 20, right? Multiplication first. On the left, 81 minus 40 should be less than or equal to 7 plus 2 times 20, which is 40. On the right, well, on the left first, you have what? 81 minus 40 would be 41, less than or equal to 7 plus 40, 47. Is that a true statement? Yes, it is. Well, this is the answer. If you want, you can check the others, but you will be done, okay? That's one way. The other way will be to solve your inequality. Always remember how to do that, right? Less than or equal to 7 plus 2m, okay? I want to have my m's on the left. Let's do it that way because I want to show you, I want to remind you about what's happening when you multiply or divide by negative numbers. I'm going to take this 2m from the right, 2m from the left. You solve exactly the same way we solve an equation. What you have, 81 minus 2m will be minus 4m, right? If you don't believe me, just think about minus 2m minus 2m, right? Negative 2m minus 2m. When you subtract, you add the opposite, right? So you basically have to add two expressions with the same sign. Minus 2m, which will make 4m with the same sign, negative 4m, right? Good. Less than or equal to 7, 2m minus 2m would be nothing. Next thing, take that 81 away from both sides, right? Which gives me what? 81 minus 81, nothing. On the left I will have negative 4m. Less than or equal to 7 minus 81 will be basically 7 minus 81. 7 minus 81 will be, you add the opposite, right? Will be 7 plus negative 81. What is the rule? Subtract the small one from the largest one. 81 minus 7 gives you 74, right? Keep the sign of the largest one. So less than or equal to negative 74. Now if you want to find m, you're going to divide by negative 4 both sides, okay? And Next, let's do some housekeeping here, some cleaning. Hold on. Okay. Negative 4m divided by negative 4m is going to be m. Right, so we're going here. M. Now, because you're dividing by a negative number, your inequality sign switches, right? Flips. And you have negative divided by negative is going to be positive. 74 and 4. Well, first of all, 4 and 74 are even. If you want, you can simplify by 2, right? 4 divided by 2 is 2. 74 divided by 2 will be what? 37. 37 divided by 2 will give you 18.5. Okay? So for any m greater than or equal to 18.5, that inequality will be true. Well, obviously we have only 20 that's greater than that, and that's, this is the way in which you solve it by the inequality solving method. Moving on. Which property is demonstrated? 30 plus negative 30 plus 3 equals negative 30 plus 30 plus 3. Well, first of all, you have commutative property of addition, associative property of addition, commutative property of subtraction. Well, we don't have any subtraction, right? Associative property of multiplication, we don't have any multiplication. Is it commutative or is it associative? What do you guys notice? We only have a switching of places, which means this is the commutative property. Okay. Okay, let's try one more. Combine the like terms to simplify the expression. Like terms, right? We like them, we may not like them, but they have to look alike, right? And for that, you're looking for each one of the terms in this expression here that will have the same variables at the same power. Let's start with the first one, and I recommend you guys to follow the same way I'm doing it here. You're going to underline it, 17p squared. I'm looking for another p squared. I have one right here, minus 7p squared. Well, that's all, right? No more p squared in here. But 17p squared minus 7p squared is going to be 10p squared, whatever that is, right? Next thing, q squared. I have 8q squared. I have 2q squared here, negative 2q squared, right? Let's simplify that. Let's combine it because there is no other q squared in here. 8q squared minus 2q squared equals 6q squared, right? And the only term left in here will be p plus p. You always take the sign that's in front, all right? And this is the answer to your problem. Okay, this is how you combine them. This is how you have to follow. Those are the steps. Do the dance. You will have similar problems on the test. Best of luck. Use the distributive property to simplify the expression. How should we solve a problem like this? Well, first, as you notice, you have a parenthesis. Okay, you can go ahead with that and see what's happening, and I will do that first, because order of operations says multiply before you subtract or add, and let's go that way. So I have first number 8 stays the same. Next, you multiply 3 to everything inside the parentheses, but what you have in front of your 3, you have a negative, right? I have negative 3 times 3 will be 9, minus 9. Then I have minus, right? That minus 3 times negative 2x. What is 3 times negative 2x? You have to be careful here because you're multiplying 3 times negative 2x, and that will be negative 6x. And I'm doing it this way. I should have said, well, minus times minus will be plus, but I'm trying to show you guys how am I doing that. So you keep the sign that's in front of your 3, minus, but then you multiply 3 to your negative 2x, right? Because that's what you have in front of your 2x here inside the parentheses. And minus 7, moving on. I have 8 minus 9. I can go ahead with that and just do it. What is 8 minus 9? 8 minus 9 will be the same as 8 plus the opposite of 9, which is 8 plus negative 9, and that will be negative 1, right? 9 minus 8 is 1. Keep the sign of 9 because it's the greatest one. Negative 1. Now minus negative 6, you add the opposite, so the plus 6x minus 7, right? Next step, I have a free term here and a free term over there. I have negative 1 minus 7. Negative 1 minus 7. What I said, when you subtract, you add the opposite. Okay? Minus 1 plus negative 7 will be negative 8. So the first thing I can write will be 6x minus 8, or plus negative 8 will be 6x minus 8. And this is the answer to this problem. Be careful, especially when you multiply, or when you have a negative number outside the parenthesis and a negative number inside, or if anything else would be positive, you're changing signs, right? Be careful with that. Okay, next one. Looks like my tablet. Alright, next one. What is the value of negative a if a equals negative 3.125? Now this is a hard problem, right? We're talking about opposite. If a equals negative 3.125, negative a will be the opposite of that number. The opposite of that number is the same number in absolute value with a different sign. And this is the answer. Okay? List the odd numbers between 8 and 16 in a set notation, right? Set notation, you have to use these symbols for the set, right? Between, which means you're not including 8 and 16. What is the next odd number after 8? 8, 9. 10 is even, not good. 11, right? 12, 13, 14, 15, and you are done because you list all the odd numbers between 8 and 16. This will be the answer. You're moving on to the next problem. Moving on to the next problem, if my tablet will allow us to move. Okay, and this is the last problem for today's lesson. Simplify using the distributive property. Show each step of your work. Okay, simplify. Well, like in the previous problem, the one before the previous actually, I'm going to multiply that 3 to everything inside the parentheses. My expression becomes 2x plus 5y, you're not changing in any way, plus 3 times 2x. 3 times 2 is 6x. 3 times negative 3y is going to be negative 9y, right? Minus 7x. Okay? Next step, I'm looking for like terms. 2x, 6x, minus 7x, right? And eventually my tablet will allow me to write 2x, 6x, minus 7x. 2x plus 6x is going to be 8x minus 7x would be 1x. We're not writing the 1. By putting x, we imply there is 1x. Next one, 5y minus 9y. 5 minus 9. 5 minus 9, you change both signs on the number that gets subtracted. You have 5 plus negative 9. Because you're adding two integers with different signs, you subtract the small one from the largest one, right? 9 minus 5 is 4, and you keep the sign of the largest one. It will be minus 4 what? Y. And this is the answer to this problem. Okay? We are done. Please move on and study more for the review. Take test part 1. And then submit via Dropbox the second part of the test. Thank you guys. I'll see you soon.